In this video, we're going to talk about the development of the law of cosines. So the law of cosines accompanies the law of sines to allow us to use trigonometric functions to determine information about non-right triangles. Now, if you remember, the law of sines was really grounded in the idea that if you draw an altitude in one of these non-right triangles, its length h could be represented in different ways. And when you set equal the different expressions that represent the lengths of the altitudes, you end up developing these identities for the different ratios of the sine of an angle measure to the side length opposite it. Well, the law of cosines is similar, but instead of figuring out the length of h in different ways, we're going to use Pythagorean theorem to try to see if we can develop any kind of insights about the relationship between the information in these triangles, regardless of their side lengths and measures. So key to this is going to be recognizing that when you draw this altitude, you're going to split the side length, the length of AC, right, that was b units long. So this whole thing is b units long. You're going to split it into two lengths, and we don't exactly know what those lengths are. So what I'm going to do is I'm just going to say, well, this length is some unknown length x, meaning that whatever length is left over is the difference in what the original length is and however long that piece that's x units long is. I've drawn this a little bit nicer in this second diagram. So we're going to work off of this idea. And let's begin by writing a couple statements we know to be true because of the Pythagorean theorem. So remember, the Pythagorean theorem states that the square of the lengths of the two legs of a right triangle is always equal to, the sum of those is always equal to the square of the length of the hypotenuse. So in this case, for this triangle, and we can just put a little vertex D if we want to help to name the triangle. So triangle ABD, its leg lengths are x and h. So we can say that x squared plus h squared has to be equal to c squared. And on this triangle here, triangle CDB, we have the side length h squared. We have a side length b minus x, so that length squared has got to be equal to the hypotenuse length, in this case, which is a squared. Let's begin with this second one. We'll come back and use that first equality in a few minutes. So we have that a squared is equal to h squared plus b minus x squared. Now let's go ahead and expand b minus x squared. So this is b minus x times b minus x. So that's b squared minus bx plus x squared, if you remember your properties of how to expand binomials, the product of binomials. Combined like terms, we have a negative 1bx and a negative 1bx. So that's going to be minus 2bx. So let's come over here and add that in. So h squared plus b squared minus 2bx plus x squared. Now this is where we're going to come back up to this other equality that we had. So if we rewrite this, let's solve this for h squared. So we have x squared plus h squared equals c squared, but that would mean that h squared is going to be equal to c squared minus x squared. So just subtract x squared from both sides, we get this equality. The reason we do that is because we've got h squared within this statement down here, and we want to replace it with a term that contains things that we can cancel and combine with in the other terms here. So if h squared has got to be equivalent to c squared minus x squared, then a squared will be equal to, we replace h squared with c squared minus x squared, plus what's left. Now, if you look closely here, we can combine some like terms. So we have a negative x squared and we have a positive x squared. And no matter what the value of x is, when we add negative x squared and positive x squared together, we get 0. So that's going to leave us with a squared is going to be c squared plus b squared equals 2 times b times x. Now we're almost to the law of cosines. We just have one more step. And that's we want to replace this x with an expression that involves just a, b's, and c's, and measures of different angles. So coming back up to this triangle here, you might recognize that if we look at the measure of angle A, that the x value, right, the value that we see here in our formula, the value of x, is the hypotenuse length of that triangle times the cosine of the measure of angle A. So let's replace x in our formula with that equality. So we're gonna replace x with c times the cosine of the measure of angle A. So we get a squared is equal to c squared plus b squared minus 2 times b times c times cosine of the measure of angle A, once we replace x with that. This is the law of cosines. So you'll see that what the law of cosines does is it relates the length of a side, A, with the length or the cosine of the measure of the angle across from A, and in relation to the two side lengths that are on either side of the angle A. So going back to the original sort of clean diagram here, the side length A is being related to, it's being expressed in terms of the cosine of the measure of angle A and the lengths C and B. So in other words, the known information we would have to use this formula, is we'd have to know two side lengths and the measure of the angle in between formed by those side lengths. And what this will allow us to do is figure out what the side length is that's across from angle A. Now I'm not going to go ahead and do this other development, but if you turn the triangle and you do it in different ways, you're going to figure out that the other possible combinations here are also true. So for example, if you know the measure of angle B, and you know the side lengths C and A, so you know CA, and you know the measure of angle B, if you evaluate that and take the square root, you can figure out the length of B, which is the side length that's across from angle B. And finally, again, if you know measure of angle C, and you know the lengths A and B, so you know A and B, and you know the measure of angle C, you know everything on this side of the equality, then we can use this to figure out the length of C, which is the side length across from angle C. Now when you're given a definition box for the law of cosines, you're generally given all three of these equalities. And it can be a lot to remember, it can look a little overwhelming, but just remember that the basic idea is if you want to figure out some unknown side length, and you know the angle measure across from it, and you know the side lengths that are next to that angle, you've got all the information you need to use the law of cosines, and these side lengths that are going to go here in the positions on the right-hand side of the equation are just going to be those side lengths that are on either side of the angle measure you know, and the cosine of that measure, the measure of that angle that you know, and you're going to be able to use that to figure out the side length across from it. In the rest of this investigation, we're going to use this law, this property, many times to figure out information about the triangles, and you'll get a lot of practice with how to use and interpret the law.